Hello, this is Charlie Berger. I'm the Senior Director of Product Management for Oracle Data Mining and Advanced Analytics. And welcome to this webinar where I'll be talking about big data analytics using Oracle Advanced Analytics 12c and BigDataSQL. And the theme of this whole presentation is that we're really trying to make big data and analytics combined simple. And so let's get on with the webinar. First of all, Oracle is always required to provide a safe harbor statement about any implied or inferred impressions about futures. So there's the safe harbor statement. Now, in the area of big data and analytics, there's a few things that are at least of interest to me, at least. And one of them is that there is this huge growth of data, but if you contrast that to the amount of capable data scientists, there's quite a mismatch there. There's way more data to be analyzed than there are data scientists. So there's also a corollary to this, which is the amount of data that is produced versus the amount of data that actually gets used. And executives feel that they just have a very small sort of percentage of the data they actually collect is analyzed and used. So if you infer from this, some conclusions, you might say, at least these are my conclusions, that any data analysis platform that you're going to use, it really should be extremely powerful and able to handle very large volumes of data. It ought to be really, really easy to use, and it ought to be highly automated and enable deployment. Because if you are going to spend the time to go off and build a predictive analytics methodology of some sort to predict churn or cross-selling or whatever you're trying to do, you really do want to make sure that that whole methodology is able to be automated and deployed, so it gets way past the data scientist or data analyst's office and deployed out through the enterprise. So people have been doing this for a while now. Hadoop, I think, is now 10 years old. Databases and data warehouses have been around for much longer than that. And yet you see a lot of platform sprawl. Okay, you see people using different special dedicated data analysis tools, be it either SAS or SPSS or R. You see people with different databases, a lot of Excel. And there's a lot of problems inherent in that. There's a lot of duplicated data. You're moving data around quite a bit. You have security challenges because although you may store and manage the data in your data warehouse, by the time you move it off to your analytical server, you may have violated all those security assumptions. You have problems with backups, a lot of problems. So what we try to do is, to the best that we can, we try to minimize this platform sprawl. And with Oracle, we're trying to make it simple, so we have fewer and fewer moving parts. We have, the database. We make the database intelligent and smart, so you can do the analytics inside the database. We have our Hadoop Big Data Appliance. We put analytics on the Hadoop appliance, and we also have something called BigDataSQL, which I think is a little bit of a secret sauce that pulls all these things together quite nicely. So our vision at Oracle is to create a big data and analytics platform for the era of big data and the cloud. The key is and analytics, because it doesn't make any sense to separate the two. In 2015, you can not only manage your data, but you can ask for the square root of a value. You can ask for the log of a value, and today you can ask for a neural network or a decision tree or a clustering algorithm to also look at that data. With Oracle, we're trying to keep things simple, so you can manage any data size, any variety of data in a variety of different combinations of data, structured data, unstructured data, transactional data. You can combine all these things together quite nicely in the database. So big data and analytics is made much simpler because you can just do it right there in the same spot, let the data analyst into the controlled environment of the DBA, who has the whole IT platform and the privileges and the schemas and the security, duplication and backup. You don't have to send the data off to other places for the analysis. And more importantly, if and when those data analysts come up with very good analytical and predictive models, you want to deploy them. You want to deploy them all through the organization, whether it's on the cloud or as a service or as an application. However you want to deploy those recommendations or those real-time fraud alerts or those customer profiles at an ATM device within an application or within a BI dashboard, you want to make that as simple and easy to productionize, if you will. And if you have fewer and fewer moving parts, if your database can do it all, or your database and your big data appliance using BigDataSQL can do it all, you have 2 or 3 at most moving parts, 1 or 2. Not 16 different tools to try and do all these individual tasks. So Oracle's been at this for a period of time. We've been doing this for about 15 years. We've been stem selling very powerful advanced analytical functions deep inside the kernel of the Oracle database, starting way back in 1999 when Oracle acquired a company called Thinking Machines. I and a bunch of us came to Oracle through that technology acquisition. And what we've been doing since then is figuring out how to put a very complicated machine learning algorithm, like a neural network or something like that, inside the kernel, the SQL kernel of a relational database. And you might say, well, how do you do that? Well, it's not so easily done. So what we did was, in the beginning, we looked at, well, what does a database do well? And one of the things the database does very well is it counts. So our early algorithms were NB, naive Bayes, and AR association rules back in 2002. And these were algorithms that were based on simple counting principles. We count the number of times a person buys a cereal, and they also buy bananas, and they also buy milk, and we have a conditional probability rule defined at that point. We know if cereal and if bananas, they probably also want to buy milk. Similarly, the naive Bayes is assuming independence between all the variables, and we can do similar sort of predictive models, assuming age, income, what they bought, whatever. And based on the past being a predictor of the future, we can mine that data, build very good and accurate predictive models, and then deploy that throughout the enterprise. Now, since then, we've grown and evolved quite a bit. And so now, in 2015, you have over 15 high-performance machine learning algorithms that are sort of analytical jackhammers that reside natively inside the SQL kernel of the database. So if you want to do clustering or classification or regression or associations analysis or detection of anomalous transactions or records, all of these are now high-performance machine learning algorithm implementations that take advantage of all the parallelism and scalability and security and all of the features of the database, because they are the database. In fact, at this point, I always like to kind of show the simplicity of this. If you see over here, I have I'm logging into my little laptop here with a SQL Plus instance, and I'm just going to try and get that attention right here. I guess that's not working for some reason. Why is that not working? Okay. There we go. So as you can see, this is just the Oracle database. It's release 12. I have Advanced Analytics is an installed option that's already part of the database installation here. So if you have the Oracle database and you have 11G or 12 or soon 12.2, you already have the Oracle Advanced Analytics option installed as just a standard part of the database. So it's very straightforward, very easy. Now, so if I were to summarize what I'm talking about here in one slide, it would be this slide. It is the Oracle Advanced Analytics database option. We have a library of about 15 high-performance in-database data mining algorithms. We also integrate with open source R algorithms, so you can use both what's in the database and you can use R syntax, SQL syntax, or the Oracle Data Miner graphical user interface to access this functionality. And you can also do callouts to open source R and call some function that maybe we don't have, at least yet, high-performance implementations of that algorithm supported inside the database. The algorithms that we support are going to be scalable, parallel in-database execution of those algorithms. And again, you can use SQL, like say SQL Developer, and just drop into pure SQL. You can use R, any kind of R, like RStudio IDE, or you can use the drag and drop SQL Developer graphical user interface, which also, by the way, generates SQL code for immediate deployment and PL/SQL. It has a PL/SQL API, so you can just schedule and run the workflows that you've created. Because Oracle Advanced Analytics is an integrated component of the database, it makes model building and model deployment easy. It's just all part of the all part of the database. And because of the simplicity and the fewer moving parts that we provide, it really is the best platform for enabling enterprise-wide analytical applications. So the difference, contrasting Oracle Advanced Analytics to traditional analytical platforms, is that with traditional platforms, you have to do the data extraction. If a data analyst wants to build a model on churn or attrition or cross-selling or fraud, what's the first thing they do? They say, DBA, can you please give me some data? I need to perform some analysis on that data. And they go and they ask for a copy of the data. This may take several minutes. It may take more likely several hours. It's the human time between all these steps that really sort of slows the whole process down. So they're taking extracts of the data. Then in the world of the analytical tool like SAS or SPSS or R, they are oftentimes doing data preparation steps. Things like, oh, I know what last year's bonus was and this year's bonus. Those are two good variables. I'd like to create a new variable called the difference between the two to see if bonuses were going up or down. And then after a little while, they decide, oh, I'd like to create another variable which says what's their bonus amount compared to their peers, because word gets around. And then you have all these derived variables that are happening outside of the database. Then you run your algorithms, you learn the patterns. You can do that in SAS, SPSS, R, or in our case, natively inside the database. Once you've built a good model and you want to deploy that, you have to repeat all of those data transformations that you did, run the scoring, and then, in this case, import the results or try to figure out how to recode that model logic and run it as a native function inside the database. All that takes a lot of time. It requires you to have a separate platform, and it just makes things more complicated. So doing this all as one application inside the Oracle database really helps most customers that I deal with. They'll say that what used to take me several days or several weeks, now I can do in several minutes or seconds or a few hours at worst case. So it really is the fastest way to deliver enterprise-wide predictive analytics and really to leverage your investment in Oracle technology and your Oracle data. So you can really think of Oracle Advanced Analytics like this, whereas you solve a lot of analytical problems using SQL. SQL's been around for, I think, 40 years now. You can do selects, select distinct, aggregates, where, group by, rank. You can do a lot with pure SQL, but you can do a lot more with the analytical SQL verbs that we've added to the database. So now I can select customers where they've maybe made a large purchase in the past, and I predict they're going to default on a loan, or I predict they're going to buy something else, or I identify what segment or cluster they belong to. I can identify the key factors. I can do associations or market basket analysis. All these are things that are just very powerful analytical verbs that now exist inside the Oracle database. And I can access those very powerful analytical verbs via their native SQL functions. I can also, with our very, very tight, probably the industry's best integration with R, I can integrate open source R language and talk to those same analytical verbs and thereby get huge scalability. So what used to be, something I could do in R to, say, summarize some data or build a decision tree and use small amounts of data, now I can use that same syntax but access the powerful in-database implementations of that. So we do a function pushdown. We transparently map that to the equivalent SQL functions for those analytical functions that we've natively implemented inside the Oracle database. And as I said before, if you need to do a call out, you can do that as well. So what does this have for impact? Well, depending on your situation, it can be quite substantial. Turkcell is one of our public references that I really like, and I like all of our public references, but Turkcell is a really good one because they were managing hundreds and hundreds of terabytes of data for telco calls, and they were using another traditional statistics package, and this was taking them 2 or 3 weeks to go through this whole process of trying to stop a prepaid phone card. And what they did was they just looked at the logic, they looked at what they were using to build the regression models in this other statistical package, and they just said, I can get that same data together, it's natively inside the database, before I ship it outside to some analytical tool, I'll just rebuild the same type of model inside the database using the Oracle Advanced Analytics functionality, and that's what they did. And they've cut their time down to just a couple of hours for detecting any kind of prepaid fraudulent phone card use case. So it's a wonderfully simple and easy implementation that has a huge dollar impact. So to sort of set the stage at a very high level, what we're talking about here is the Oracle Database Enterprise Edition option with the Oracle Advanced Analytics option. It installs by default. So you have the Database Enterprise Edition with the Oracle Advanced Analytics option installed. You can access that, so data or business analysts that want to sort of use a drag and drop paradigm, and I'll go through a quick demo of this. For those that want to use a drag and drop or paradigm, they can use SQL Developer's Oracle Data Miner extension. It's called Oracle Data Miner. It's a drag and drop workflow. If you're an R user, you can use the R client, R Studio, something like that. That's what I use usually. And you can connect into the database and you can use your R syntax, and now you're you're driving against data tables and views that are inside the database using R commands that map to the equivalent SQL functions. Once you've developed a predictive model and you want to share those results with either through an OBIEE dashboard or maybe integrate that into some sort of application, well, any of these applications that can talk SQL can talk to the results or the live predictive model and ask it to do its thing and give a prediction. So all of that can be done very easily if your data source, your data repository, is not only a data management platform but an analytical platform as well. And who wants a dumb database? You want your database to be able to both store and think about the data that it's managing for you. For the data analyst or quants or data scientist, they oftentimes just want to see, well, Charlie, show me the list of algorithms that you support. What do you support? So here are the list of the high performance in database algorithms. These are accessible via SQL or R or GUI. And of course, we have logistic regressions and decision trees and so on of the classification data types where you're trying to separate a population into, A's and B's or yeses or no's or churners and non-churners. What's different about these algorithms, and in fact different about all of the algorithms, is that they not only ingest and consume well-behaved two-dimensional tables of rows and columns, but because of their native in-database implementation, they can mine star schema data. So if you have transactional data, you don't have to explode that out to, let's say you had 2,000 products at Walmart that you were keeping track of, or Target or some sort of retail store. You don't have to explode those out into columns for each and every SKU. That doesn't make a whole lot of sense. What you do is just leave the data in its native sparse form, and when you analyze a person's behavior, you say, well, here's their age and their income and how many children they have, and then here are the transactions or the purchases that they've made. And those just come in as a very sparse representation, sort of a nested column, and we ingest the data in that form. Similarly, if you have unstructured data, like here's the customer, here's what they've purchased, here's their age and income, but you also have, here are their customer comments, or here's some recent emails, or here's their resume, or here's the physician's report, or the nurse's notes, or the police report. All of that unstructured data is also fair game. And so you'll see the word text next to, I didn't put it in every one of them, but it's in every one of them. If you have unstructured data, we use Oracle Text to take that unstructured data, to tokenize that, to sort of break it up into a bag of words, a vector of words. And if you use the word discount, let's say 3 times as often as the larger population, then that's equivalent as having, let's say, your height or your age or your income be 3 times as much as everyone else. So we'll just say, well, how often does that person use each of these different words? And those will become part of your profile that we'll analyze just like any of the rest of the data. So we have all of the algorithms, I think, that any other good data analysis, data mining, predictive analytics platform would offer. What's different about ours is they're able to mine star schema data in its native form, and the models and the logic all are natively residing as just part of the Oracle database. The models that you create at the end of your analysis are just first-class objects. I could build them with my privs, and I can give them to somebody else to use them, but maybe not have the ability to edit them unless I, sort of edit them myself and authorize that and republish them. Here's a slightly larger list. I like to show that because the ones in red indicate those algorithms or statistical techniques like SQL patterns or aggregations or recoding, tests for correlations with t-tests, Pearson's, and ANOVA. These are all things that come free in every Oracle database down to the standard edition. And then with the Oracle Advanced Analytics option through our integration with R, if you want to run any open source package, we can do that via embedded R. So we can't claim that the latest and greatest package you just downloaded off of CRAN, that we're going to somehow magically make that highly parallelized. But if you need a random forest or a time series, and let's say we don't have support for a time series algorithm just yet, well, what you can do is you can use the database to do a lot of the heavy lifting, like totaling all the sales data by SKU and transaction, bucketizing that into weekly or monthly buckets. And at the very last moment, once you've got that vector of data with all your purchases, and you want to throw that out to an ARIMA model to make some sort of time series forecast, well, you can do a call out to an open source package using Oracle R Enterprise Embedded Mode, and then the results can be returned back to the database or left in R. So essentially, we can do everything that we can do natively in the database and do it in a very performant way. But if there's 1 or 2 or 10 things you need to do that are outside the database, you can do that too. And that also applies to graphs. If you want to take and run a graph and then put it into an OBIEE dashboard as a ping file or something, there's a lot of things you can do. And if you Google Oracle R Enterprise blog, you'll see a lot of good examples there. So I always like to show this. So a lot of data scientists pride themselves on having the most sophisticated, most complicated, most intelligently derived and created algorithm and analytical methodology. That's what they do. But remember the Netflix challenge that happened a few years back. Someone did win it. They won $1 million for coming up with an algorithm that was supposedly, better than the recommendations that Netflix was able to do for which movie you should watch. However, notice, the rest of the story is they never actually productionized it. They never put it into implementation. Why? Because as you can read, the implementation of that was just too much infrastructure, too much effort to productionize that whole methodology. So it was a great algorithm, but it was never used. And that will never happen with Oracle because the algorithms just are natively part of your IT platform. There's nothing special to do. It's just part of the database. So you'll never run into this sort of situation if you build your predictive analytics methodologies inside the database using the Oracle Advanced Analytics option. So I always like to back this up a little bit. A lot of people look at this and they say, well, what is data mining in general? What is it doing? I'm trying to find patterns. I'm trying to find relationships. What is data mining? The concept of data mining is that it's automatically, and that's the key word here, it's automatically sifting through large amounts of data to find previously hidden patterns, discover new valuable insights, and ultimately oftentimes to make predictions. And depending on what you're trying to do, there are different techniques. So if you're trying to identify the most important factors, like here, I'm trying to take a bunch of data and say, what are the factors, attribute 1, 2, 3, 4, 5? Which attributes are the ones that have the most powerful impact or influence on my business, like say profitability or customers that churn? I might use an attribute importance. And of course, we have support for an attribute importance algorithm. If you're trying to predict customer behavior, well, that's a classification type of technique where I'm doing supervised learning. I have examples of people who have churned and people who didn't churn, or people that bought the more than $500 worth of shoes and people that didn't buy more than $500 worth of shoes. And I have a lot of historical data. So we have four plus algorithms for doing classification: logistic regression, support vector machine, naive Bayes, decision trees, and neural networks for doing that. So there's a lot of algorithms for doing classification. Similarly, for regression, we have support vector machines and regression models. If you're trying to find profiles of customers in a supervised way, you might use a decision tree. If you're trying to segment the customers and try to find natural populations, then you might use a clustering algorithm. So there are a lot of different types of things that you do with data mining and algorithms, and I think it's safe to say that we have all of the main workhorse algorithms are implemented in a high-performance, scalable, parallelized implementation inside the Oracle database as part of the Oracle Advanced Analytics option. I'd like to show this for a brief and simple example of what you're doing with data mining. Let's say you have only two variables, income and customer months, and you're trying to figure out, can I build a predictive model that separates or classifies records as either likely to be cell phone churners or loyal customers in blue? So if I remember back to my high school math and I try to fit a straight line through some data, well, it can do that, but it's fairly simple. If I try to fit more of a quadratic or a cubic model, I might pick up some more of the blues over here and separate all the reds over here, but it's still relatively simple. And I have to know what type of fit and form I want to try and apply to the data. If I use a machine learning algorithm, let's say like a decision tree, it'll find these patterns and these cut points by iterating through every possible value of customer months until it finds a point here where it notices a real difference. Same thing with income, and it'll iterate and iterate and iterate until it finally carves this up and reaches a stopping criteria and says, okay, well, I found a number of different segments and I can explain even my logic in this case using a decision tree. I found that if customer months is greater than 14 and income's less than $90,000 right here, then 8 out of 8 of these individuals have all churned. So if I find a new customer that fits this profile, I can say, well, they're probably going to churn. I have a 100% confidence using the past as a predictor. And support is 8 out of a total of 39 people on this chart have in fact churned. So now I can assume that I have about a 25% market share here, the people that are leaving with this behavior. Here's another market segment with slightly different behavior, and armed with this information, I now have much greater insight and can make better and smarter predictions, and hence compete against my competitors by having extracted more more value out of my Oracle data. So there's a lot of different ways that people start doing data mining. They typically come with questions like, I want to predict employees that voluntarily churn, or I want to predict customers that churn, or who are my best customers, or I want to sell more products so I can make some more profits, or who are my best customers, and how do I combat fraud? Or my favorite, I've got all this data, can you mine it and find a bunch of useful insights? And please don't do that. What you want to do is you want to really carefully define your problem, and there are methods that people use in the field of data mining to solve data-driven problems. And what we do inside the database is the same. Okay, everything, nothing's really very different, but in fact, everything is quite different. So if you look at the beginning, I want to start with a business problem, a well-defined statement. A little bit more on that in a minute. I want to say, well, who are my best customers? Are they all people that spent more than $1,000 in the last year? What is it that I'm really looking for? Then the very next step is the key one. Most people say, well, of course, I'm going to extract that data, move it out to some statistic or data mining package for the analysis. We're going to say, no, leave the data right where it is. In fact, join more data to that, use all the data and generate more derived new variables and such. So assemble the right data for the problem, maybe create new derived variables like, what's the maximum temperature during the last 3 months, or how many checks did they write in the long window of time, and how many checks did they write more recently. And I can use things like the SQL windowing functions. I can be very creative in my analytical methodologies because there's just so much analytical and SQL functionality in the database that either the data analyst or a combination of the data analyst working closely with their DBA, they can really assemble the right data and do it rather quickly. And then when they're done, they can transform that data to actionable insights quite easily. And most importantly, they can deploy that enterprise-wide almost immediately, right? If they're using this Oracle Data Miner GUI, they just right mouse click at the end and say generate the code, or save this whole workflow and just schedule it to run it tonight at midnight, or whatever you want to do. Deploy the models in real time. So back to those problem statements that we had before, if you're trying to predict employees that leave or customers that churn, maybe a better way of saying that would be, based on past employees that voluntarily left, create a new attribute, employee turnover, yes, no, and give it a 0 or a 1. Same thing on churners, assign it a yes, no. For your best customers, maybe do a little bit of recency, frequency, monetary analysis and specify who has spent more than $500 in the most recent 18 months. Flag those people as your best customers. So these are the kind of things you can do using all of the power of the Oracle database, using all the data that you have access to inside the Oracle database. And then at the end of all that, then these naturally map into different algorithms, or maybe combinations of algorithms. Maybe I want to do some clustering and find natural populations of people, maybe all the left-handed people over here and all the right-handed people there, or all the people that buy frequently in small amounts, or the people that buy infrequently in large amounts. And then for each of these clusters, maybe I want to feed those into separate analytical models. It's very easy to do that, to assign, to combine analytical methodologies together. It's just a flow inside the database, and you can pipeline results. The output of one model can be the input to another model. It's very easily accomplished inside the database. So here's some very brief demos. I'm going to cut over to the first. I'm going to cut over to the Oracle Data Miner graphical user interface, and this is part of SQL Developer. So I'm using SQL Developer, and there are different extensions to SQL Developer. I'm using the Oracle Data Miner extension here, and this is eventually what I'm gonna build. But I'm gonna start up at the top here. I'm gonna say, okay, let's take a data source and let's try to pick something. When we do the training and when we ship the product, we use a lot of this kind of customer insurance lifetime value data set. It has a bunch of different variables that deal with age, income, lifetime value, marital status. There's a lot of variables here. So we're going to look at that. This data now is a table. So if I view that data, SQL Developer is pointing directly at the table that's there. The data is still inside the database, and the SQL that I'm using to view that data is right here generated as well, because I'm just using SQL Developer for this. Now, if I want to explore this data, one of the very first steps with data analysis is oftentimes, well, first you need to understand your data. So let's go through here and let's say we want to do some sort of analysis. We want to group these by, let's say, lifetime value bin. I want to calculate a bunch of statistics on my data, min, max, skewness, kurtosis, things that I may want to visualize in some way. When I run this, notice the workflow is going to be saved, because if I like this workflow, I may want to share it and give it to somebody else to use. I can save the workflow, share the workflow, deploy the code, whatever I want to do. And when I run that, the database is just taking that script and saying, pulling it off the queue and just deciding to run it. So now if I go through here and say I want to view the results, what it's done is for each variable grouped by low, medium, high, and very high values, it's gone off here and done some quick analysis. Now here are people that buy insurance and don't buy. That's going to be another part of the problem I'm going to kind of delve into. And so then for each of the different variables, it gives me little thumbnails grouped by a variable, and I can change that around rather easily. The next thing I might want to do is do a little bit of filtering the columns. Now, we put this in because if you're going to hook up some very powerful machine learning algorithms to your tables in the database, you may have a lot of data and a lot of variables, and you may want to have some automated data quality. So to get rid of variables, or at least suggest ones that have too many nulls or too many distincts, I can also nest in here this attribute importance that says, you'll see this in a minute, I'm going to have a certain amount of sampling that's going to occur, randomized or stratified sampling. If your data is unbalanced, we're going to automatically sort of stratify the sample to balance that out into a little bit more of an equal fuel mixture of data going into the algorithms. And then if I run this, then that's going to run something called a minimum description length algorithm, and it's going to look at all the data with respect to the target field. It's also going to have those data quality checks, and it's going to say, well, here are the variables that have the strongest correlation with people buying insurance, yes or no. And on the right-hand side, you're going to see some variables are all constants, some of them are all nulls. I guess there's not too many nulls. And over here on the right, it's going to tell me that I suggest that some of these variables just don't make a lot of sense here. So if I want to take these variables here and light them all up and then say apply my recommended output settings, it'll turn off all those variables. So I can do that, turns them all off. I'm going to leave them all in right now just to keep going, to keep it nice and simple. And the next thing I'm going to do is a classification model. Now I'm not going to go through all this. I'm going to cut over in a minute, but I just want to show you how this connects up to here. When I set this up to run, I'm going to specify my target variable. My case ID is going to be customer ID, and my inputs are going to be the variables I had before. I can turn this on or off. If I have certain variables, I always joke, but if I have certain variables like marital status, and I say that that's text, then over here, a lot of machinery sort of wakes up, and I can say, well, what languages do I want to use? Am I doing a stopped words list? And all of the unstructured data is going to be automatically sort of structurized and sent to the algorithms as a vector of words, and word term frequency inverse document frequency is what we call it. So that's going to be coming as a vector of words if that were character large object type of unstructured data. It's not, so I'm just going to use married, single, divorce, whatever here. Now, as I run this, see if I have this all set up. I'm going to put this on automatic here. If I have this all set up, then I'm just going to run this now. And when that runs, it's just going to set up a queue in the database to say, go off and build me 4 different kinds of models. So down here, you can see that we're building a generalized linear model, a support vector machine. Now, there are intelligent defaults we set up for all of these. If you want to override these and change them to your own settings, you can. The kernel on the support vector machine will be system determined. It may be linear, it may be Gaussian, it all depends. For test, it's going to have a holdout sample of a 40% holdout sample. And so it's going to do all this a lot of machinery, if you will, all in an automated fashion. And then if I want to view my results, I have various different model metrics I provide, with like lift charts and ROC and so on, where I can see which model seems to give the highest lift. And it would seem like maybe this model up here, I think that's the naive Bayes maybe, or the decision tree. It comes in pretty well here. So that's the target value. We'll see yes, and I can see it for no, and so on. So I might want to view these models. A lot of people like the decision trees because they're so sort of visual. And so I can start with the top of my population. I can see that the most of the people are in fact not buying insurance. But if I sort of walk down my decision tree and go down a little bit later, I see a few more people that in fact do buy insurance. If I keep on going a little bit lower, down here to the bottom, I can find people that a lot of them do buy insurance. I can see the whole rule that's been discovered inside the data. And so I have different rules. for each of the different segments and different probabilities and confidence levels of people buying insurance at different rates and confidence based on the data that's inside the database. So if I like what I've done and I want to deploy this as a model, all I have to do here is just say, well, I want to deploy this, and it will set up the SQL code, and I can give that off to the DBA to immediately deploy this. Or I can save this workflow and share it with somebody else, export the workflow. I also have another one over here I wanted to show. This is a little bit more of a complicated one. This is doing some aggregation. So I've got my sales data. I'm aggregating the amount sold and the quantity sold. I'm feeding that in with some customers' data. I think I have somewhere in here some unstructured data in the model. I'm doing some clustering, so I'm doing a little bit more involved analysis there. I can do a lot of different things. I've got market basket analysis over here. If I want to do, what things go with what, I can do a market basket analysis. If you buy this and this, it's also likely to go with that. I have other things for fraud detection, so I have various different models I can do for detecting anomalies and so on. So a lot of functionality. You can solve a lot of different types of problems. Now, cutting over to R. If I am using R, I can do pretty much the same thing. Okay, I've got a connection from R over here. So when I first set this up, what I want to do is I want to set up my connection here. And I've already run that. So way up here at the top somewhere, it'll say I've loaded all these packages. I'm all set and ready to go. If I say, well, now that I've connected, I'd like to see, well, what are the tables that I have access to? These are the tables that I have access to in the database. If I want to get a little bit of R help, I can get access to that. If I want to say, well, I just want to do some summary statistics. Well, this is a case where all the min, max, standard deviations, those are implemented already as high-performance SQL functions of that, so I can do that inside the database. If I want to graph anything, I have all of R's rich graph capabilities here. If I want to do something like this, now this may not be advised if I have lots and lots of data, because it's going to do a lot of graphing here, and you may just want to take a sample of that. It's R, in this case, the graphing widget, the graphing engine of R, the R client in this case it's going to be using all the memory of single-threaded R to do that. But if I want to do something like this, do a support vector machine model that is now mapping to, this is just a demo that comes with the product. If I want to do a support vector machine type of model where I'm doing that inside the database, then I am doing that now, mapping the R syntax to the in-database SQL functions, and I'm using R, but I'm driving the parallelized implementation of that same support vector machine algorithm we saw previous. So I'm speaking R, but I'm getting the parallelism and the scalability and the elimination of data movement that comes with having moved algorithms inside the database. So that's a few real quick demos. I'll come back to a couple more in a minute. So here's that other example I started out showing before. And there's a lot of, I think, very interesting things here. One is I'm dealing with transactional data, and I'm aggregating that all together. So I don't have to explode these out as separate columns. I'm just taking all the transactional data and using the strengths of the database for doing what the database does well. I call this out explicitly here, but I actually don't have to. It's just embedded in the other modeling node, so it's actually part of this node here as well if I want to just run it the way I showed you before. But I wanted to call out that we are in fact mining unstructured data. Here's a cool thing. I have inserted an inline predictive model because you may have what the person's credit rating score is, but I want to have my own opinion. I want to have my own predictive model. Same thing could apply for things like, do you have a criminal record? What's the value of your home? I may get that off one source, but I may want to take a fly at that inside the database, use my own algorithms and math. Why? Because the database can do these kind of things. I join this all together and get a very more complete 360 perspective of the customer. I can join thousands and thousands of variables together here, or attributes. When I'm done, I've got all my multiple predictive models. I've got my one or multiple predictions. I can take a panel of experts at the end of the day, or I can take the output of this, goes to the input of something else, and I can just generate the SQL scripts or take this API workflow and go immediately to deployment. So what could be easier, right? It's the fastest way to go from data to enterprise-wide predictive analytics applications, is what we often say. I always like this guy's quote. Essentially, this is George Box, one of the most influential statisticians of the 20th century and a real pioneer. And he always said, essentially, all models are wrong. They're not perfect, but some of them are useful. And here's an example, dunnhumby. Dunnhumby is one of my other favorite customer references. They have this process where they look at all the customer data and what they buy at the stores each day and each week, and they aggregate that all together, and they churn through all that data, and they build predictive models. Well, all the cranking through all that data and trying to get ready to see what do they put in the weekly flyers, the weekly promotions, was taking the better part of a week, and they knew as they got more data, they had to change the way they did things. So they went with Oracle Exadata and the Oracle Advanced Analytics option, and they've gotten this whole process down to under 4 hours now, and they just keep on going and doing more things. And that's kind of an example of what's possible when you merge together the strengths of a database and the algorithms and put them into the same platform rather than having two separate worlds. Here's Dunkin' Donuts, another great customer reference story. They spoke at Oracle World last year, as have Turkcell and dunnhumby. dunnhumby is now 8451. They've changed their name, actually. I forgot about that. So dunnhumby, they do a lot of market basket analysis. And here they're trying to find what goes with coffee. And some items they make more profit on than others. So they're really trying to figure out when I have my customers, and Dunkin' has also gone to a loyalty card recently. So they have all this data about the customers and what they've purchased. And now I can tailor promotional offers to the customers, suggest the right thing. So they're off on doing a number of different sort of data-driven big data analytics problem solving at Dunkin' Donuts these days. Now, in the demos, I think I showed this before. I just always like to call this out. When I'm done with my analysis, I can just generate the SQL script, and it takes a snapshot of what I was doing, and it just generates all the code, and I can feed this off to my DBA and deploy it like that same day. If I want to drop straight into the SQL and just write a program, and some of the guys just want to do that, I just want to have a very automated script of some sort. Well, I have that over here as well. And I'm just going to show you how I do that here. Here's an anomaly detection script. I'm going to update the settings table here. So I've done that, one row inserted. And now I'm going to actually build the model here. So this is what I'm building the model. That'll just take a second or two. So I've done automatic data preparation, done all my transformations. It built a model in about a second. And now when I'm done, I say I want to score everybody and show me the top 5. That's what I'm doing here. So here's now the top 5 most suspicious expense reports, people, transactions, whatever. And what could be easier? If I just want to run this whole thing again and run that on a daily basis or whatever, I can just do that as a script inside the database whenever I want. Runs the whole thing, updates, there we go. Now, also that model that exists, that prediction probability, that claims model here is a decision tree model. So here, I'm trying to show the case where maybe I've previously built a model, and I'm going to say, what's the likelihood this person is going to buy or not buy or commit a crime or whatever? Well, that model exists as a first-class object inside the database. It's very live. If I just change those values and rerun it, I get a whole new prediction. So, what could be easier? The data, the models, it's all part of the database. It's all driven by SQL, via R, or via GUI, so it's very easy to, let's think about building applications, and that's what we've been doing at Oracle. So that's an example of a fraud-based application. Here's the real-time recommendation that could be put in a social media or an ATM machine or on the web, however you want to do that, a call center. Very easily done. I want to switch gears just for a minute and talk about another different type of algorithm. When you lack examples, you're trying to find rare events. You're trying to find them. Maybe it's fraud. Maybe it's unusual people. Whatever. You don't have a lot of examples. So what do you do there? You take all of the data that you have, x1, x2, x3, all of the different variables, and you learn on what you believe to be normal records. Learning on normal records allows you to, kind of like a cop or a policeman that knows his neighborhood, knows he's been walking the beat for 5 years. He knows when Mr. Jones leaves the store or leaves the house, and when Mrs. Jones, leaves the house. And he knows all these patterns. He knows what they typically wear. So I've learned on that data, and I've not memorized, but essentially memorized it. Now I can take that knowledge, that pattern of all that past data, and apply it to new records and flag those ones that stand out as being the most dissimilar to the rest of the population. If I want to then build some sort of tax non-compliant methodology, I can do that. I just take the tax data. I can find the most anomalous records. If I have a lot of examples, I can build a classifier. Here I'm building an unsupervised learning sort of anomaly detection algorithm. So I can combine these together. So it's very easy to build pretty sophisticated analytical methodologies inside the database. R, we've been talking about R. R is just another interface into these same algorithms, and it provides so much more. Okay, R is a very popular, it's taught in all the schools. Anybody that's learning statistics or analysis these days is learning R. It has some great strengths. It's free, it's open source. People are constantly contributing to the open source R community, and people are learning how to program in R. Its challenges are that it's memory constrained, it's single threaded, it's not really ever really considered as being very industrial strength. Now, there's attempts to make it stronger and better, and we applaud all those. But what we've done is saying, well, let's take the strengths and the beauty of R, and let's map that to the strengths and beauty of what's inside the database. So here, I'm going to take my R script, and I'm going to transparently, using the R2SQL transparency framework, and when you say aggregate or select or whatever in R, we're going to map it to an equivalent aggregator select inside the database. So all of your base R language is going to be invisibly and transparently translated to SQL for you. So you type R, you get the power and scalability of SQL. When you go to use an algorithm, well, as I said in the beginning, I can't take all 6,000 or more R packages and suddenly claim that I can take all that C code and make it parallelized. But if you say I want to build a decision tree or a clustering algorithm, and you use the k-means or the decision tree or the expectation maximization clustering algorithm that we have inside the database, now you can use your same R language to drive very powerful in-database implementations of those same familiar algorithms. And you just bind much more data and many more variables and so on. And if I do have the situation where there is an R package or an R graph widget or something I want to do, I can always do a call out, and we do that through something called embedded R. So we can let the database do most of the work, and at a certain point it can do a call out, ask the R package to do something. R server in that case is mounted on the same server as the database, maybe moving less data, shorter distances, and doing all the math on a beefier server, because that's where the database is also installed. And so I'm shortening that whole sort of loop, and I'm able to extend what we provide with Oracle Advanced Analytics through the tight integration with open source R packages as well. And here's a brief sort of PowerPoint demo of that. Let's say I'm using an aggregate function. Well, through the transparency layer, the Oracle R Enterprise Client package maps that to equivalent SQL and runs that in a parallelized in-database implementation and returns the results. So that's very sort of powerful. If I'm going to do something like a support vector machine algorithm, well, similarly, I want to convert that to the equivalent SQL, just like what I showed before. It's going to do that in a very parallelized, highly performant in-database implementation. So the data is not going to move. The model is going to be inside the database, but I'm using my R syntax to get my models and my results using the familiar R language. And if I want to be bilingual and use R sometimes and SQL other times, or use GUI, I have all these different options available to me. There's also something called the Oracle Advanced Analytics for Hadoop option. So there's something called the Oracle Big Data Appliance that stores and works with data in Hadoop format, and the Oracle ORAAH is part of the Big Data software connectors. It provides a transparency layer that allows certain overloaded R functions to operate on Hive tables using R syntax and behavior. So it's going to translate R to Hive SQL, and the Oracle R Advanced Analytics for Hadoop provides a range of predictive algorithms that execute in a parallelized fashion on the Hadoop Big Data Appliance as well. So that's another option for you to consider. It's not really the primary focus of this talk. What I wanted to talk about here was something that I think is very easy to do, very easy to implement. In the other one, you have to learn a little bit of you have to program in R, or know a little bit about working with Hadoop. Here, if you have big data and you know SQL and you get the Big Data Appliance combined with Exadata, there's a new option called BigDataSQL. And what it does is it does push down of the SQL predicates to the storage layers. So backing up a little bit, what gives Exadata its extreme performance? Well, it is the offloaded query to the Exadata storage servers. Essentially, we push the SQL predicate selection functions down to the hardware layer of the Oracle database. And so with BigDataSQL, we overcome this challenge. We say, well, you may have some data in MapReduce, some data in NoSQL. What you really want is the ability to use your common language of SQL to access all of that data, and that's what BigDataSQL does. So now, through the power of Oracle SQL, you can get access to all those different data types, structured, unstructured. You can use all the rich analytical functions of SQL, And in our case, with BigDataSQL, if you're running the SQL and you have a data reservoir or a data lake, whatever you want to call it, and you have a bunch of sensor data and you have the mins, the maximums of temperatures taken throughout the course of the day, or you have the number of times or a counter on how many times the person goes through certain tolls on a highway or geospatial data, all of that data that you're collecting in high volume on the Hadoop server, well, all of that data can be aggregated, filtered, counted, synopsized, and joined with the rest of the data that you have inside the Oracle database. So through BigDataSQL, you can really extend your reach, cast out a much larger, wider net out to all of the larger new big data sources, and still join that data with your other data of known value that's inside the Oracle database and build very powerful and accurate predictive models. So we now can manage and analyze all of your data. So I think that's really powerful. And if you're using the Oracle Data Miner GUI, for example, we have something we've added called a JSON query node. And if you have the data on the big data appliance mapped as an external table, well, the JSON query node is going to parse that out. You're going to join to the rest of the data, and you keep on going. It's from the same user interface. So there's a lot of simplicities. As I said in the beginning, we're trying to make big data and analytics combined simple. And what does that provide you? What does that give you? Well, a lot of people, they'll start trying to build, the perfect model with the perfect algorithm, and they'll have like 5, 10, or 20 variables. And you can get a certain lift, a certain incremental accuracy from adding 20 variables and having a very good neural network or decision tree or whatever. But oftentimes, if you think about what data you need, like counters of how many times the car goes through, trafficy areas or accident-prone areas, the more data that you can add to your model, if it's the right data and you think about it, and where's that data? It's either going to be on your big data appliance or in the database. The more you can add more of the right data and have an algorithmic platform that can ingest all that data, the better off you're going to be. So now with BigDataSQL and Oracle Advanced Analytics, you can model and mine. You can mine lots and lots of variables, lots and lots of data, structured data, unstructured data, web visits, sensor data. Lots and lots of data is out there to be mined. A lot of digital exhaust from your customers, and you can build a much better model. And it's very simple to do, right? It's just all part of your SQL platform, whether or not you're accessing that from R or GUI or SQL. So what kind of impact might that have? Here's another customer reference, Wargaming. And Wargaming uses the big data appliance, and they were running predictive models in just 3 minutes instead of more than 6 hours. They were combining data from Hadoop, big data, and the database, and just being able to much more rapidly sift through the data and dealing. And in this case, they're dealing with lots and lots of hundreds of millions of players here. So it's just another quick example of what's possible. And you can go to the website. I put them in all the bottoms of the slides. You can read the more detailed stories. So where's this all going? To me, this is all going more in the realm of applications, and I think that's where it's really exciting. So all of this data, where is it? The data, the results, the models, they're all just part of the database. So you can leave the data and then access that data through OBIE. Here's or Cognos or Tableau, whatever you use. Here's an Oracle Business Intelligence Administrative layer. Here is an example of one of my favorite ones, the Oracle Communications Industry Data Model, that allows us to do a clustering of different types of customers. And then for each cluster of customers, if I click on it, it takes me directly to the predictions of each of those customers churning, each of those customers leaving. So the data, the variables that I need to build the models, the modeling logic, it's all just part of the database platform and allows me to build much more intelligent BI dashboards and applications. Here's another application for human capital management that we've built. This is called Predictive Workforce. And here, for each of the different employees, we predict the likelihood they're going to leave. We show the highest ranking variable that has the strongest influence or correlation with the person leaving. And we even provide what-if analysis. What if you were to change the input values? What would you get for new predictions? Now, going back to the Oracle Communications data model, we have 6 different pre-built predictive models. Here's the churn prediction, and if I click on this, it goes directly to the documentation, so you can see the different models. Here's the churn prediction, and then here are the variables that the domain experts in telecommunications working with the analytical we analytical guys have put together the variables that are used to build the predictive model, and then that just becomes part of a combined pre-built solution. And you can see the profiles of different customers. You can see the predictions. It's all just part of a complete pre-built solution. Similarly, if in the communications we know who you make your texts and your calls to and from, well, it doesn't take that much more effort to say, well, I can figure out who your top 25 friends and families are. And in the communications world, if one of my friends and families leave to a different carrier, apparently I'm now 2 or 3 times more likely to churn to another carrier than I was before that person left. So the impact of my friends and family and their situation greatly influences me. So if I'm going to try and build a very good churn model, I have all that data. I might as well use it. And here we build predictive models for that as well. So I want to cut over just to show you a few of these things. Hopefully this social network analysis is still live here. So we've built a few different social network analysis app modules. I'm not going to try and go into all those, and hopefully this has pages expired here. So this is, if I can get this guy to go again here. This is, it was that graphic that I had before. See if I can just sort of relaunch this guy here. So this is now, well, let me just cut back to that. This is the churn graph that I had before. This is part of the Oracle Business Intelligence sample application. And here I've done predictions of the number of high-value customers, low, medium, and very high value. These are not totals. These are individual predictions that I've aggregated and then placed on a map. And in this application, there are a bunch of different what-if scoring functions, and I can do market basket analysis. I can do a number of different things here. So these were a few just sort of live, semi-live examples I wanted to show of how easy it is to take the results and push it into some sort of dashboard or application. Just want to close with a few additional things here. Some of the new features, and I've covered this in the latest release of SQL Developer Oracle Data Miner 4.1. We've added a new graph node. We've added a SQL query node. We've added the script generation JSON query node. We've also added 3 new algorithms and done a number of different things in the 12c release. Here's the graph node. I didn't have time to show this, but if I want to just do a scatter plot or a box plot or a line chart, just an individual specific graph of some sort, I can do that very easily using the GUI. If I have a SQL query node, we sometimes call this our analytical duct tape node, because I can do any kind of custom SQL script here, like a recency, frequency, monetary type of calculation. I can generate SQL code for automation. I think I covered that earlier. We use the SQL query node also to integrate previously registered R scripts. So if I have some sort of R script for doing linear regression model or a random forest model, I can register those, and assuming that R piece of it is a small piece of something larger that's better done in the workflow, I can just integrate that as part of the workflow using the SQL query node. So it allows me to extend what I would ordinarily have done using the power of R here. If I'm going to do pure 100% in R, I'd probably stay in the world of R. But in this case, I'm extending what I was doing with a little bit more of some R functions I thought I needed access to. Here are the new algorithms, the expectation maximization clustering algorithm. We've added principal components analysis and also SVD. In the text, I covered this before, where I'm taking unstructured data, just defining that to be text. And a lot of machinery wakes up and then structurizes your unstructured data, and you can ingest that in the models quite easily. And the last new feature I want to show, I think just about last new feature, are the predictive queries. What are PQs or predictive queries? They are completely 100% lights out model build using all the intelligent defaults, model apply. We throw the models away and we just return the results. So if you just want to say, show me the top 10% most anomalous expense records, or show me the customers who are 80% and above likely to buy a car or whatever, it's just a query. It's going to be completely automated. The idea is that if you're going to take the time for a data analyst to do all the work, they're probably going to take these intelligent defaults anyway. So why not just run it? Now, could a smart data analyst or data scientist build a better model? Yeah, maybe not. But you may not even get to doing a model in the first place if you try to do it perfectly all the time. So this has taken our best shot of complete automation, and it works really rather well. JSON query nodes, one of the new features in Oracle Data Miner 4.0 for dealing with unstructured data stored either in the database or mapping to an external table on the Big Data appliance. And the last new feature, the 4.1 Oracle Data Miner Workflow API to manage, schedule, and run workflow. So once you've built your whole workflow, now you can just sort of lights out, just run the thing. Very, very powerful capability. You just schedule that whenever you want to. So how do I get started? Well, there's a lot of different ways to get started. One is to, if you send me an email, I usually have these favorite links. So if you send an email to charlie.berger, B-E-R-G-E-R, at oracle.com, what I showed in the beginning, I'll send you pretty much this list, and you can click on it. You'll see the YouTube videos that are out there. You'll see a white paper that I've just recently authored. You'll see the various different OTN pages. A lot of these pieces of information are also out here on OTN. So if you go straight to OTN or you click on the Learn More tab, you'll see all the Learn More. You'll see the white paper. You'll see presentations. You'll see learning tutorials on how to get started. On the data mining sub-component, Oracle data mining component, you'll see similar information with the documentation and the algorithms and so on. On the R Enterprise, you'll see the same sort of thing with a lot of information here and links to learning more and training. On the blog, there's a number of different things on the blog that you can go out there and get. So if you want to see like the Oracle Data Miner 4.1 SQL extension now available and so on, there's a lot of good things on the data mining in the Oracle R Enterprise blogs. Here's the white paper I talked about before, which I think is a wonderful read if you want to. Sort of has a lot of the presentation I'm going through here written down. And then we have these Oracle by examples. And the Oracle by examples are free online tutorials that take you, say, maybe 45 minutes. And if you follow this Oracle by example, it'll kind of take you step by step of what you need to do to get going. And then it's just the documentation there. So there's a number of links and resources to get you started. There's a couple of great books out there. One written by a great guy, Brendan Tierney. He's an Oracle ACE director. Wrote Predictive Analytics using Oracle Data Miner. You can get that off Amazon. Written by Mark Hornick, one of the people on the Oracle Advanced Analytics R Enterprise team. Has written Unlock R, using R to unlock the value of big data. Another great book. So you get these two great books and get going. Also, through a partner, Vlamis Software, there is the ability to just go straight to their website, fill out a brief registration form, and they will send you a connection to log on using a remote desktop connection, and then you can just sort of launch a whole session here and take a 3-hour test drive using Oracle Advanced Analytics. If you use up to 3 hours and you run over, you can just start it all over again and set the clock again and just go for another 3 hours. Last thing I wanted to say was we have a annual Oracle Business Intelligence, Oracle BIWA, Business Intelligence Warehousing and Analytics Summit. Is the Big Data and Analytics User Conference that we have once a year. It's going to be out at Oracle headquarters campus at the conference center, January 26th, 27th, and the 28th is a half day. Really welcome you to come on out and do that. We're also doing some call for abstracts that's going on right now, so hopefully you can join us for that. With that, I have to end it. There's no Q&A here because it's just a recording, but thank you very, very much for your time. And again, if you have any questions or feedback, you can enter them in the comments at the bottom of the YouTube page, or you can send me an email at charlie.berger@oracle.com. Thank you very much.